Yes. Hello students. So let us start with a new chapter, stereochemistry. Stereochemistry. So what do you mean by a stereochemistry? How can you simply define a stereochemistry? In stereochemistry, as the name suggests, it is a spatial chemistry. That means, here you will see two or more compounds which just differ in their spatial arrangement of atom. If you write the structure, sometimes it will be very similar, but you will see the spatial arrangement are different. For example, one atom is in this side for one compound. Other cases you will see that atoms in this side. So basically, the difference is the spatial arrangement. So such compounds that we'll call stereo compounds. And here now the study of stereoisomers that we will say stereochemistry. So we will discuss what is isomers, everything. So let us define what is stereochemistry. This is the study of stereoisomers, where you can see two or more compounds are differ each other in their spatial arrangement of atom. Spatial arrangement of atom. Spatial arrangement of atoms. So that what we can say is a stereochemistry or not stereoisomers. So first of all, before going to stereoisomers, let us define what you mean by an isomer. Just we can discuss the classification, then we can move to the what is stereoisomers is all about, different compounds, etc. So please write it down, then we can learn what do you mean by an isomer. Isomer. Isomers means we know organic compounds can form millions of compounds. There is no real limit. Now more than 90% of the compounds are now carbon based compounds. So we can see that's a real beauty. Uh, Real what is carbon is all about. Carbon has the catenation property. That catenation property is responsible for this huge number of compounds. So here you will see what I mean by what do you mean by an isomer. Isomer means two or more compounds, organic compounds basically, are differ each other in their structures or spatial arrangement of atom. Spatial arrangement of atom. Which is having same molecular formula. So you will see two or more compound which having same molecular formula, but the difference is their structure may be different, the spatial arrangement of atoms may be different. So that is the main difference between among in isomers. Okay, so same number of same molecular formula means number of atoms will same. For example, 6 carbon, 12 hydrogen in a particular compound. You will see another compound having 6 carbon and 12 hydrogen, but the difference is the structure may be different, or the spatial arrangement may be different. So we can say they are isomers because they have same molecular formula, but only difference is no there they may be structure different or no in spatial arrangement may be different. So we can classify isomers basically into two. Isomers into two. They are structural isomers and stereoisomers. Okay. So as the name suggests, in structural isomers, they differ each other in their structures. Stereoisomers, spatial arrangement. That will be the difference. Now, this structural isomer we can still classify. Let us first of all list out what are the important structural isomers. First one I can say chain isomers. Chain isomers, as the name suggests, they are different between chain. We can discuss one by one with examples. Second one, position isomers. Position isomers. That's the second one. Third one, functional isomers. Functional isomers. Okay, the fourth one I can tell you, metamerism. That's another types of structural isomers. Metamerism. Okay, the next one I can tell you, that is ring chain isomers. Ring chain isomers. Okay, next one, tautomerism. Tautomerism. So these are the important structural isomers that we are discussing. Chain isomers, position isomers, functional isomers, metamerism, ring chain isomers, tautomerism. So these are the important structural isomers we have. Stereoisomers, yes, they are also different classification is there. One we can say configurational isomers, and the next one is conformational isomers. Conformational isomers. So that's the way you can classify stereoisomers. This configuration isomers are still two classification is there. One is no geometrical isomers. Geometrical isomers. Another one we can say optical isomers. Optical isomers. Okay, so this is the basic way we can classify isomers. So what are them? So first of all, what is isomers? They have same molecular formula, but their structure is different, or spatial arrangement of atoms is different. Such compounds we can say isomers. Okay, isomers are classified mainly into two. They are structural isomers. Another one is stereoisomers. Structural isomers means there we can see their different will be in their structures, and if the difference in the spatial arrangement, that we call stereoisomers. So basically we have to discuss more about stereoisomers. There are plenty of that to discuss, so we will discuss in the next class. Today we can discuss more about the structural isomers. So what are the important classifications in structural isomers? Chain isomers, position isomers, functional isomers, metamerism, ring chain isomers, finally tautomerism. So please note down this along with the class. We can discuss each structural isomers first. So first important classification was chain isomers. Chain isomers. Okay, so always now you can learn chemistry through examples. So let me give one example. We know N-butane normally have a structure. But means 4 carbon, C, 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 C. N means every carbon is singly bonded. So rest of the valency, carbon has a valency that is 4. Rest of the valency has to be satisfied by hydrogen. So CH3 will be there. Then here 2 hydrogen is only required because 2 valency is already done. So 2 more hydrogen. Next again 2 hydrogen. Then here 3 hydrogen is required because only 3 hydrogen is satisfied. So this is normal N-butane, right? So CH3, CH2, CH2, CH3. Now this is, we can say, the complete structure. This is not the condensed form. Simply we can write like this: CH3, CH2, CH2, CH3. That is N-butane for you. Now this compound now having 4 carbon atoms, you can see 4 carbon. How many hydrogen? 3 plus 2 plus 2 plus 3. That means no 10 hydrogen, right? And one more thing you can note, that is no, this is an alkane. So alkane having a general formula. What is that? Alkane having a general formula CN H2N plus 2. So easily you can write the molecular formula. Having, if you know the number of carbon atom, put N is equal to 4. If you want to get butane, N is equal to 4. 4 into 2, 8 plus 2, 10. So it will be, so C4H10. So general formula alkane will be C4H10. There are 4 hydrogen and 10, sorry, 4 carbon, 10 hydrogen. Now let us take now the same a compound which I am going to write, which is having same molecular formula, but now differ in their structures. Especially now chain is changing right now. There I drawn a 4 carbon chain, right? So this time I am writing a 3 carbon chain with 1 carbon branch. Okay. Now you have to supply hydrogen. 1, 2, 3 is done, 1 more hydrogen is required. Here 1, 2, 3 is already done, only 1 hydrogen is required. Here 1, 2, 3 is done, 1 more hydrogen. So it will be CH3, here also 1, 2, 3 hydrogen. So CH3, CH, CH3, CH3. Now you see how many carbon? 1, 2, 3, 4 carbon. How many hydrogen? Here again 10 hydrogen, 3 plus 3 plus 3 plus 1, 10 hydrogen. So molecular formula again C4H10. So no doubt these two are isomers, N-butane, and what's the name of this compound? Yeah, longest chain is actually 3 carbon chain, that is 2-methyl propane. Because longest chain is 3 carbon chain, so my root name is prop. N stands for carbon carbon single bond. There is a second carbon, there is a branch is there, 1 carbon branch. So this is 2 methyl. If you name it 1, 2, 3. If you number it, second carbon you will see a methyl branch. So this is 2 methyl propane. So that's all about the another compound. Now these two compounds have different property. That what you have to understand. This compound and this compound not have similar property. Their melting point, boiling point, other chemical properties will differ. Because now this is another compound. This is another compound. Like now two different people. Like that. This is another, I will say another structure. Chain, difference in their chains. This is a 4 carbon chain, this is simply 3 carbon chain. You can see the structure is also changed, property also changed. So this is chain isomers for you. So a compound having a molecular formula C4H10 having two structural isomers, that I will say N-butane and 2-methyl propane. So now let us discuss now another compound. This time now having a molecular formula C5, C5H12, C5H12. So this is the general formula of alkane. So it has to be an alkane. 4, 5 carbon. 1, 2, 3, 4, 5. Rest will be hydrogen that you can supply. Now it will be if I write the condensed form, it will be CH3, CH2, 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 CH3. 3 plus 2, 5, 5 plus 2, 7, 7 plus 7 plus 2, 9, 9 plus 3, 12. So this will be C5H12 formula. That is N-pentane. N-pentane. Pent stands for 5 carbon. N stands for carbon-carbon single bond. So this is N-pentane. Now let us try to make the structural chain isomers. Here, now 5 carbon chains. So let me decrease the branch. Sorry, let me decrease the number of carbon atom by putting one carbon branch. CH3, CH3, CH2, CH3. So here you will see the longest chain is actually 1, 2, 3, 4 carbon chain. Okay, you cannot go and go reverse. That is not possible. Longest chain you have to select. You have to start from one end. You have to end other end. And the branches substituent should get branched carbon. Substituent carbon should get minimum number. That's the UPSC rule for you. So here, second carbon atom having a branch. Longest chain is 4 carbon chain. So it has to be 2 methyl butane. 2 methyl butane. That is definitely chain isomers. 5 carbon, total 5 carbon. Count the number of hydrogen atom. 12 hydrogen atom. So same molecular formula C5H12, another chain isomers. Okay. Now think. Now if I look at this compound I derived from here, I put methyl in the second carbon atom, right? So I got another chain. If I put now methyl branch in the third carbon atom, will it make another compound? No, because let us check CH3, CH2, CH, CH3, CH3. So now different between, if you look at the structure you will see it's different. This compound, no, it was somewhere here, this down that side. No, because no, according to IUPAC rule you have to name in such a manner the branched carbon should get minimum number. So if I number from here 1, 2, 3, I am getting a branched carbon with a number that is 3. That should not be no possible. So I have to start from here to get a minimum number. Okay. So which means these two are identical compound. You cannot say these two are no an isomer because you are actually representing the same structure, same compound. So either one you can select. Either you can draw like this or this. Basically they same. They are what? Same compound. So understand that. Just remember the rules that we studied before. So let us come back to this. This is another chain isomers. Now let me try to make one more. This is 4 carbon chain. Let us try to make 3 carbon chain. 1, 2, 3. 1, 2 branches. Here hydrogen is required? No. 1, 2, 3, 4 is already done. So no hydrogen is required. Here 3, here 3, here 3, here 3. Molecular formula C 1, 2, 3, 4, 5. 5 carbon. 3 plus 3 plus 3 plus 3. That is C5H12. That is molecular formula same. Differ in their structure. Then it should have a different name. So let us name it. Here longest chain that you get will be 3 carbon chain. So this is 2 dimethyl propane. 2 dimethyl propane. That will be the structure of what? This compound. So actually you are getting 3 chain isomers which having a molecular formula C5H12. One is CH3, CH2, CH2, CH3, normally N-butane. Next 2 methyl N-pentane, 2 methyl butane, 2 dimethyl propane. So now try to construct that. Along with that you will learn naming, you will write the how to write the structures, everything. So make a practice like that. That will help you. Okay. Now let me go to the next example. Here I got 3 chain isomers, right? So let me give one more example. This time the molecular formula having 6 C6H14. That means 1, 2, 3, 4, 5, 6 carbon. 1, 2, 3, 4, 5, 6 carbon. So you can supply hydrogen. 3 hydrogens required. Here 2. Here again 2. Here 2. 2. 3. So this is normal hexane. Okay, so you got a molecular formula C6H14. Try to make it, put branches, minimize the chain. So let me put 1, 2, 3, 4, 5 chain with the one branch. Here one hydrogen is required. Here 2, 2, 3. So the name of the compound will be 2-methyl. Highest chain 1, 2, 3, 4, 5. Here 2-methyl pentane. Okay, so I put branch in the second carbon atom. Now I am trying to put branch in the third carbon atom. Will it make a difference? Yes. Let us check. CH3, CH2, CHCH3, CH2, CH3. 1, 2, 3, 4, 5. So here you will see 5 longest chain, 5 carbon chain, the third carbon atom having a branch. So this is 2-methyl pentane. This has to be different. This is at the third carbon atom we have a branch. So this is 3-methyl pentane. So you actually getting another compound. Doesn't think no this is same. No, this is different. One is 2-methyl pentane, another is 3-methyl pentane. So that's all about 2 chain isomers that you got. Can you make more? Just check. This time now I want to put 1, 2, I put 2 chain. Okay, 1, 2, 3, 4, 5. I put 2 chain back to back. So it will be CH3, CH, here will be CH3, here 1, 2, 3 is done, one more hydrogen, CH3, CH3. Now check, here no second carbon atom, third carbon atom having a methyl branch. Let us 1, 2, 3, 4. So this is 2, 3 dimethyl 1, 2, 3, 4. That is butane. Longest carbon chain is but. So 2, 3 dimethyl butane. So that's the structure for what? That's the structure for this particular compound. This is 2, 3 dimethyl butane, which is having molecular formula that is C6H14, and it's another compound. Second carbon atom, third carbon atom having a methyl branch, 2, 3 dimethyl butane. So let us discuss still more is possible. Okay, let me check. This time I put a 2 branches in the same carbon atom. 1, 2, 3, 4 is already done, 5, 6. So it will be CH3, CH3. Here no hydrogen is required. Here 2 hydrogen. CH3, CCH3, CH3, CH2, CH3. So how can you name? This is 2, 2 dimethyl 1, 2, 3, 4. That is butane. Look at that, we got another chain isomer. So that's the way, you can develop isomers. You can practice as much as you can. You will see only condition is the molecular formula has to be same. You always have to get the same molecular formula. You can construct different chain isomers. Okay? So it's up to you, practice yourself. Okay. Now let us discuss the next one that I can say position isomers. Position isomers. So in position isomers, what's the basic difference that you can see? Mainly differ. Let us take one example. CH3 CH2 CH double bond CH2. Next compound CH3 CH double bond CH CH3. Let us count 3 plus 2 5 5 plus 1 6 6 plus 2 8. So this is 4 C4H8 formula. This is again 3 plus 3 6 plus 2 8 C4H8 formula. That's the general formula of alkene CnH2n. Okay, CnH2n, that is alkene for you. So here you will see what's the difference between these two compounds. Having same molecular formula, what's the difference? You will see the position of functional group has been changed. Here the double bond present in the first carbon atom, here double bond present in the second carbon atom. So if you count, you have to start with a carbon atom which having minimum number for the functional group or substituent. So here I have to start from here. So what can you name? This is but 1ene. What about this? This is second carbon atom having double bond, so but 2ene. That is but 2ene for you. Okay. So that's the way you can construct position isomers, where now you will see a difference in their position of their functional group. Another example, CH3 CH2 CH3 CH2 CH2OH. Another compound CH3 CHOH CH3. How many carbon? 3 carbon. How many hydrogen? 3 plus 2 5, 5 plus 2 7, 7 plus 1 8, 3 plus 3 6, 6 plus 1 7, 7 plus 1 8. So this is now with one oxygen, one oxygen. So basically they have same molecular formula. What's the difference? Let us check. Here first carbon atom having a OH functional group. Here second carbon atom having a OH functional group. So can you name? This is now prop 1 old. Here prop 2 old, because second carbon atom having OH. Old stands for alcohol. There is everything is ane, so everything is singly bonded. So there is prop 1 old and prop 2 old. They are example for position isomers. Okay, so let us move to the next. This time functional isomers. Functional isomers. So as the name suggests, here no, the functional group itself will change. For example, CH3 CH2OH. Here next example, CH3O CH3. Okay. How many carbon? Let me draw one more CH3C. Okay, that's won't work, right? CH3. Ketone won't work. Let me check. These two. Here now 2 carbon and here also 2 carbon. 3 plus 2, 5 plus 1, 6 hydrogen. 3 plus 3, 6 hydrogen and 1 oxygen. So they are isomers, no doubt about it. But you can see different functional group. One is OH, which is coming in the category of alcohol. One is O, that is ether, which means no, two classes of organic compounds having different functional group. So here I can name, this is one, or now I can one ethanol. Okay, simply ethanol. Or now here now naming of ether is just different, where now you will see a heteroatom like oxygen coming in the main chain, so you have to separately name. Here carbon chain. No, after oxygen you will see one carbon chain, and before also you will see another carbon chain. So how can you understand ether from the name? It will be oxygen is there, which means oxy is the root name, so it will be methoxymethane. That's the name you can give for what? This compound. So one is an ether, another is a alcohol, which having same molecular formula. So they are what? They are functional isomers. Next one, CH3CO, CH3. Then CH3, CH2, CHO. 3 plus 3, 6. 3 plus 2 plus 1 hydrogen. 6 hydrogen. 1 oxygen, 1 oxygen. 3 carbon, 3 carbon. Okay, molecular formula is same. So what's the difference? One is keton, one is aldehyde. So let us check. This is 2 propanone, or you can name prop 2 on. Ons is the root name for ketone. What about aldehyde? It is NAR. So it will be 1 propanol or prop 1R. So it's a very good name. So that is, it's all about specific. You have to specify it. That's all. Sometimes one is not required. Simply putting propanol means no. Nal stands for aldehyde. So basically that will be in the first carbon. So you generally don't represent as well. Putting one won't be there. If it is any other carbon position, you have to specify it. So that's two different compound which having same molecular formula, but the difference is in their functional group. So they are functional isomers. Always learn to construct organic compounds, which means no organic chemistry will be so easy for you. Next, I will say metamerism. Metamerism, as the name suggests, metamerism stands for what? Let us check. Metamerism. Here you can see, let me give an example. CH3O, CH3O, CH2, CH2, CH3. Another compound, CH3, CH2O, CH2, CH3. So basically these two are ethers, no doubt functional group is not really changed. What's the change? Here you will see different number of alkyl groups after oxygen and before oxygen. So now we know either has to name separately, right? So here these are different compounds, merely different. What's the difference? In the structure you can see some difference. There are different alkyl groups after oxygen and before oxygen, so naming will be different. Here always select the longest carbon chain as the parent name. So one methyl group and one propyl group is there. So how can you name? This is methoxypropane. Methoxypropane is the name. Here 2 carbon chain and 2 carbon chain. So does it make any difference? This is ethoxy ethane. So we can say they are compounds showing metamerism. One more example, CH3, CO, CH2, CH2, CH3. Next one, CH3, CH2, CO, CH2, CH3. So these are two different compounds which having same functional group, that is ketone, but the difference is here you will see 2, 1, 2, 3, 4, 5. So pentanone, or specifically you can name pent2on. Pent2on. Okay, so this is third carbon atom having a ketone group. This is third or no. Let me check. This is bench 3 on. So you can see different types of structures but having different atoms between the between the alkyl group. There is some different here two, here also two, but here after the functional group you will see three groups, here one group. So that's a different, that's a simple different, but it's actually a different compound as well. So that is metamerism. The next one, ring chain isomers. Ring chain isomers. So what does mean by ring chain isomer? Here now you can see one ring, another one is an open chain compound. So this is now how can you name? 4 carbon is there. It's a cyclic compound. So this is cyclobutane. Let me write the one of the open structure. CH3, CH2, CH double bond CH2. Okay, so the difference is now 4 carbon, how many hydrogen? Remember, here 2 bond is satisfied, rest will be hydrogen. So 2 hydrogen, 2 hydrogen, 2 hydrogen, 2 hydrogen. So total molecular formula will be C4H8. Right? So here, check here how 1, 2, 3, 4 carbon, 3 plus 2, 5, 5 plus 1, 6, 6 plus 2, 8. So they are functional isomers. What's the difference? One is a ring chain compound, another one is a open chain compound. Right? Let me draw one more. This is cyclopropane because 3 cyclic chain, 3 carbon with the cyclic chain. Next CH3, CH double bond CH2. So this will be cyclopropane. This will be prop 1E. So one is an alkene, another one is a cyclic ring structure. So that's a different you will observe in a ring chain isomers. So here now one is a chain compound, another one is a open chain compound. So that will be the difference. Now, so another isomers we have done. Now what is next? Last one, tautomerism. Tautomerism. So how can you define tautomerism? Let us check. CH3 COCH3. This we know. This is propanone or acetone. If you want to specify, you can say 2-propanone. Now, you see an interesting compound which is existing in equilibrium. The same compound having an intramolecular shift. Intra means within the molecule. So now a labile carbon hydrogen bond is broken, and now that's attached to this oxygen. So now here basically it is not gone anywhere. That one hydrogen forming a pi bond here. You can see a double bond is formed, and that hydrogen is attached here. Okay, so this what is the main difference here now? One hydrogen bond here. Here 3 hydrogen is there. Here 2 hydrogen. Here a single bond is a double bond. Here it was ketone. This time it is alcohol. So these two are tautomers, which is a intramolecular shift within the same molecule, where generally a labile hydrogen atom or labile bond will be broken. That will shift, intramolecular shift will take place to form a new compound, and this we call one is a keto form, another one is a enol form, where this we call keto-enol tautomerism, where more percentage, if you consider the more amount of percentage, 99 percentage, yes, in the keto form, and another one is 0.1 percentage in the enol form. So it's more stable in the keto form, but no enol form is also there. So that's another tautomers. Now we can discuss one more, CH3N double bond O. This is nitro compound, right? Now let me see is you can draw like this. This time now, one CH bond will break. You will see that will attach here. Okay, so the difference will be CH2 double bond C. Sorry, this is nitrogen. Nitrogen OH. This is no again with a one with a double bond. So now here nothing happened to the, this is a coordinate bond, nothing happened to the coordinate bond. This double bond now broken, this time OH will be formed. Okay, you don't confuse with that here now. Let me draw same way. This is O, this is OH. Okay, CS2 double bond NOH O. Here CS2 CS3 N double bond OO. Okay, so this is not here. This form of isomerism we can call nitro C. This is nitro acetotomerism, where now you will see a labile carbon hydrogen bond is broken, and you will see double bond. Now double bond O keto group. No, this is actually nitro. CN double bond O will be broken, and you will see an OH bond will be formed. So that is now nitro acetone. Okay. So this is two examples that I can say they are tautomers having same molecular formula, but now the intramolecular shift is there between the two molecules. They are basically different compound having different functional group change. Definitely is a no very different compound. Okay, and they should have different property. This no, this OH is there. This is keto group, C double bond O group, and N double bond group O group is there, which makes it different. So these are the important structural isomers that we are discussing. What are they? Chain isomers, position isomers, functional isomers, then metamerism, then tautomerism, then ring chain isomerism. Okay, practice more compounds, learn now along with the classes. Okay, thanks for listening. Let us wind up. Okay, thank you.